Hello, Advanced Geometry students. It's Mr. Donaldson, and today we're going to talk about section 9.3. And we're going to do that in two parts. First, we're going to do a warm-up, and then we'll take some notes on that. So for the warm-up here, you're going to use the Pythagorean theorem to solve for x for the first two problems in each set. Then, or also, please make sure that you give your answers in simplified radical form. Then, see if you can identify a pattern for a shortcut for the next two problems. Right? So what I'd like for you to do is I'd like for you to pause right now, solve problems 1 and 2, and then you can resume the video and see if you got the same thing as me, and then see if you can use the pattern that you identify to solve 3 and 4 without having to do any work. So go ahead and pause the video, and then you can start again once you've done these two problems. All right, welcome back. So I'm going to go through this with you. So here we go for the first one is we're going to do 3 squared plus 3 squared is equal to x squared. You'll notice that this is an isosceles right triangle, which by the triangle sum theorem would make both of these angles 45 degrees. So this is called a 45, 45, 90 right triangle. So when I solve this now, I get 9 plus 9 equals x squared. So then 18 is equal to x squared. Therefore, x is equal to root 18. Now when I simplify this, I see that the perfect square factor there is 9. So I have 9 times 2. And then I'm going to take the square root of 9, of course, and I would get 3 root 2. So x in this problem is 3 root 2. Now for the next one, I'll set it up the same. Again, noticing that this is another isosceles right triangle, or we're going to call it a 45, 45, 90 right triangle. And I do 5 squared plus 5 squared is equal to x squared. And so then 25 plus 25 is equal to x squared. So therefore, 50 is equal to x squared, and x is equal to the square root of 50. Now this time, when we're simplifying the radical, you should hopefully notice that 50 is 25 times 2. So we know that x is equal to 5 root 2. My hope would be that you would notice a pattern here. Notice in the first triangle, the two legs were both 3, and then the hypotenuse was 3 square roots of 2. And in the second example, the legs were both 5, and the hypotenuse was 5 square roots of 2. So if I take this pattern that I recognize and I apply it in problem 3, my hope is, without doing any work, you recognize that you have an isosceles right triangle, the legs are both 6, and therefore, based on what we saw with those previous two examples, this should just be 6 times the square root of 2. What I'm hoping you notice is if the triangle is a right isosceles triangle, or a 45, 45, 90 right triangle, the legs are going to be equal, and the hypotenuse will always be whatever that leg is times root 2. So in this case, if the legs are A in this 45, 45, 90 right triangle, then x, the hypotenuse, will be A times the square root of 2. So that is the 45, 45, 90 triangle, and we're going to use that shortcut to solve problems without having to show much work, which you guys like. So the next type is called the 30, 60, 90 triangle. And the 30, 60, 90 triangle is half of an equilateral triangle. And this is how it can kind of establish part of the relationship. So originally here you've got a side that's 2A, a side that's 2A, and a side that's 2A. So it's an equilateral triangle, which would make all the degrees 60. And then when you draw the altitude in an isosceles or equilateral triangle, it's also an angle bisector. So I've cut this equilateral triangle into two 30, 60, 90 triangles. So, therefore, because I've cut this bottom in half, if the original side length was 2A, now this new leg is just 1A, and the hypotenuse is double it. And my goal today is to see, well, what does that mean that this altitude needs to be, or that longer leg? So let's take a look at the examples here. So we're going to do the same thing we did with the 45, 45, 90 triangles. I'd like for you right now to pause the video and do examples 4 and 5. So go ahead and pause, and when you're done with 4 and 5, with reduced, simplified, radical answers, unpause, and then you can follow along. All right, welcome back. So in this case, what I'm going to do is I have a 30, 60, 90 triangle. I would say 3 squared plus x squared is equal to 6 squared, in noticing that this short leg is half the hypotenuse. So I get 9 plus x squared is equal to 36. So then x squared is equal to 36. subtract 9 from both sides, I apologize. X squared is equal to 27. And then when I square root both sides, x is equal to the square root of 27. And then when I simplify that, hopefully you notice that 27 is 9 times 3. So x is equal to 9 root 3. Excuse me, making a lot of mistakes here. 3 root 3. The square root of 9 is 3, not 9. Oops. All right, so going back up and looking. In this case, I see that in a right triangle with a short leg, the leg across from 30 being 6, and the long leg, the leg across from 60, would be 3 root 3, and the hypotenuse is double that short leg. So what I notice here in this first example is that the short leg is half the hypotenuse, and the short leg to the long leg is times root 3. So let's see if that holds true in this next example. So if I do the same thing, 4 squared plus x squared is equal to 8 squared, I get 16 plus x squared is equal to 64. When I subtract 16 from both sides, I get x squared is 48. So that x is equal to the square root of 48. And then I'll take the square root of that and simplify it. So let's see. That will be 16 times 3, and the square root of 16 is 4. So I get 4 root 3. So what I notice here is that same relationship exists. In this 30, 60, 90 triangle, the short leg across from 30, to go from a hypotenuse, I'm doubling it, and to go from the short leg to the long leg, the leg across from the 60, I'm multiplying by root 3. Now, if we apply that with the next two examples, we can see how our shortcut works. In this case, this is holding true, is doubling it, without having to do the Pythagorean theorem. If I just simply multiply that 5 by root 3, I would get 5 root 3 for this leg that's across from the 60, or the long leg of this triangle. And in this general case for A, you'll notice I'm still doubling it. Times 2 gets me to the hypotenuse, and if I multiply those times the square root of 3, I get that x is equal to A root 3. So that relationship holds true. In the 30, 60, 90 triangle, whatever that short leg is, the leg across from the 30 degrees, if you want the long leg, you just multiply it by root 3. If you want the hypotenuse, you just double it. So in the notes, we're going to use these premises to solve problems without showing much work. All right, so thanks, and then you can go ahead and move on to the notes now.